Okay, so now we're going to put this all together and look at everything we've learned so that we can find solutions slash zeros of any polynomial, or most polynomials. Okay, so if I want to find all the zeros of f of x equals x to the fifth plus x to the third minus 2x squared minus 12x minus 8. Well, first I would try and see, can I factor this? This is 5 terms. I haven't learned a technique to factor 5 terms right now. So what would I do next? Well, I would go to the calculator. So here I have my calculator. So I'm going to go ahead and I'm going to go to y equals, and I'm going to put in my function. So x to the fifth plus x to the third minus 2x squared minus 12x minus 8. Okay, so first, and we talked about this before, but I would always start by doing the zoom 6. That will reset your window if your window had been changed for any reason. Okay, so this is what I see, right? And I can see it looks like I have a 0 here that maybe is a bounce, and it looks like I have a 0 here that passes through. And remember, this is a 5th degree polynomial, so we know we're looking for 5 solutions. So let's check those on our table. So on my table, I can see at -1, I do have a 0, and at +2, I do have a 0. Those are what it looks like on my graph as well, right? This looks like it's at -1, this looks like it's at +2. Now, another thing we could do, this is just another technique on the calculator, is if you do second trace, notice that the second choice here is 0. So this is a way where you can tell the calculator to look for zeros if they don't show up nicely on your table, which they don't always. So I'm just going to go through these motions just to show you this technique because it can be very helpful. So if I choose this, what the calculator is going to do is it's going to ask me to tell it where to look. So it's going to ask me for a left bound. So I'm going to find this 0. We already know it's at +2, but again, let's pretend we don't. Let's pretend that we just think it looks close to +2. So for a left bound, I want to pick an x value that I know for sure is to the left of this, but not to the left of any other 0. So for instance, I know that x equals +1 is definitely to the left of this number. So for my left bound, I'm going to type in 1. See how soon? And then I hit enter. Now it wants a right bound. And also notice I put this little triangle here. That's showing me my left bound. So for the right bound, I want to pick a number that I know for sure is to the right of this 0, but not to the right of any other 0. Now, in this case, there are no zeros to the right. But just to be safe, I'm going to pick the number 3 because I can see at x equals 3, that is definitely to the right of this number. So for my right bound, I'm going to type 3, and I'm going to hit enter. And so now here I have these 2 triangles, and the 0 that I'm looking for should be in between them. And again, that's what I'm telling the calculator to do, is I'm telling it where to look. And so I'm narrowing it down. Now it's going to ask you for a guess. The guess doesn't matter in this case, so I can just hit enter one more time. When I do that, it gave me my 0 of 2, 0. So again, we already knew that because of our table, and this one was obvious, but it's not always. So that's one thing we could do. All right, so let's write down what we got. I know that x equals -1 and x equals +2. And I also know that this, at -1, there's a bounce there, right? So that is actually occurring twice. So this has a multiplicity of 2. Now, how do we find zeros? Well, remember, and we've seen this before, if we are told what a 0 is, then we can do synthetic division. And so that's what we actually found. So we're going to go ahead and do synthetic division. We can pick either of these numbers to start with. It doesn't matter. I'm going to go ahead and start with -1. So then I'm going to do my synthetic division. And remember, the reason why we're doing this is to reduce the polynomial into something that we can solve, because we're still looking for 2 more zeros. We currently have 3 zeros because this occurs twice, and then we have this. So 0, this will be 1. What? My bad. We're adding. So that's going to be 2. Negative 1 times 2 is negative 2. Negative 2 plus negative 2 is negative 4. Negative 1 times negative 4 is positive 4. Negative 12 plus 4 is negative 8. And negative 1 times negative 8 is 8. Add those up, and we get 0. This is good because we knew that this should have been a 0. So if we did not get 0 as a remainder, then we did something wrong, or we messed up earlier on. Okay, so now I can take that remaining polynomial and I can do synthetic division with that because I got a 0. So now I'm going to do negative 1 again because I know that it had a multiplicity of 2. So these are my coefficients here. I'm just going to leave those as they are. I don't need to rewrite them. I'm going to use these coefficients, and I can ignore the remainder. So now I want you to practice. Go ahead and do the synthetic division with negative 1 in the corner and these coefficients, and we'll look at that result. Pause the video, do that, unpause when you're ready to check. Okay, so from that synthetic division, again, I should get 0 as a remainder. That means that I'm doing this correctly. If I don't get 0 as a remainder, then I did something incorrect. Now, also keep in mind that every time we do synthetic division, we reduce the degree of the polynomial by 1. So we started out with x to the 5th. This here highlighted in blue was x to the 4th. And now this here highlighted in green is x to the 3rd. And I'm going to do synthetic division one more time because I still know x equals 2 is a 0. So I'm going to take these coefficients here that I just highlighted in green. I'm going to put 2 in the corner. And I'm going to do synthetic division again. I can ignore this remainder. So again, pause the video, finish that synthetic division, unpause when you're ready to check. Okay, so here again, I hopefully got 0 as a remainder because we know that that should have been a 0, right? So let's talk this through again. This was x to the 5th here in blue. This was x to the 4th here in black. This was x to the 3rd here in purple. So this is x squared here in blue, right? And so the result that I have right now is x squared plus 0x plus 4. That's the result of my synthetic division. Now we're finding zeros, so I'm going to set that equal to 0, and I'm going to solve. Take the square root of both sides. Remember the square root of negative 1 is I, and the square root of 4 is 2. So this is going to become x equals plus or minus 2i. Now, we did a lot of work there. Let's go back up and make sure we're answering the question. So the zeros are going to be x equals plus or minus 2i, x equals negative 1, and x equals 2. This one has a multiplicity of 2. So we found 5 zeros because 2i, negative 2i, negative 1, and positive 2 are the zeros. All right, that was a lot of work. Hopefully not overly difficult though. I want you to try this one on your own. Same thing, find all the zeros. Start with your calculator though. Find as many as you can from the calculator. And sometimes the calculator can find all of them. Pause the video, unpause when you're ready to discuss. And this time I want you to go through the whole thing. Okay, so for this, I ended up with x equals 1 plus or minus I root 3, x equals 1, and x equals, well, I miswrote that, sorry. This is x equals negative 1, and x equals 1 with a multiplicity of 2. How did I get that? Okay, I got negative 1 and 1 from the calculator. We can see those here. Here's -1, here's +1. I can see that bounce. So I knew that had a multiplicity of 2. Then I started my synthetic division. I started with +1. It doesn't matter. I did my synthetic division. I got 0 as a remainder. That was good. So then I took that result here in black, and I did synthetic division with +1 again, because that had a multiplicity of 2. Did my synthetic division, got 0 as a remainder again. Now, again, just to point out, if I didn't get 0 here, either I did something wrong, or I was wrong when I assumed that it had a multiplicity of 2. Okay, so that's something that I am always checking for, thinking about. But in this case, I got 0 as a remainder. So then I did my synthetic division a third time with -1 as the 0, with the purple here, and I got 0 as a remainder again. So that was good. Now, this one was a little bit more work with what I was left over with here in the green. So this is x squared minus 2x plus 4. I would think first I would try to factor this, but it's not going to factor because nothing multiplies to +4 and adds to -2. So at this point then I can either do the quadratic formula or complete the square. I chose to complete the square, so that's the work that you see here. I subtracted the 4, and then I took the middle term, so b, I did divided by 2 squared. So that equals 1, so I added 1 to both sides. Now remember, the whole point of doing that is that creates this perfect square trinomial, which is always going to factor into two quantities that are exactly the same. So in this case, that's x minus 1 squared. And then this side becomes -3. Now I can solve, take the square root of both sides. The square root of -3 is I root 3. I need the plus or minus, and then I add the 1 over to the other side. So that's how I get x equals 1 plus or minus I root 3. And then don't forget the original values that I got from the calculator. And we knew that this was a 5th degree polynomial. So I have 1 plus I root 3 and 1 minus I root 3 as two separate solutions, -1, and then 1 occurring twice as 2 more solutions. So I have my 5 total solutions. Okay, so that's how we can use the fundamental theorem of algebra to help us finding all of the zeros of a polynomial because we understand the degree and how many solutions we're actually looking for.